Hey everyone, so in this video we want to talk about how to work with time. We could have done this topic earlier because it's kind of a universal thing, but I think in the context of simulations and particles in this case it makes more sense, and also it's a bit of a more complex topic the deeper you go into it, so I don't want to start with it in the fundamentals. So anyway, let's start simple. So what we I think already have seen, I'm not sure, but I'm pretty sure that I used it here and there, is the time shift node. So the time shift node is pretty simple and easy to understand, and one of the things I use it for is just to create a freeze frame. So for example, if I have an animation of my horse here, we've seen that before, and it looks like that, and I already limited my timeline to 100 because that's what the range of the animation is. And let's say for some reason I want to stop at this frame because it's kind of cool. I just use the time shift, and the way the time shift works is actually quite simple, and funnily enough, for some reason, including myself, beginners always struggle with understanding this node, and I think that's because it's too simple. All this node does, it's actually not shifting time or anything, it just tells in the frame parameter what frame it should currently show of whatever the input is. And by default it's set to the current frame because there's an expression on it, $frame. And that means currently it just shows the current frame. Now this is interesting or important to understand because that tells you how to create a freeze frame. It's very simple. You go to the frame you like and then you just destroy this expression by right clicking and then delete channels, or how I do it, because here's a hotkey for this already, Control Shift left mouse button, and then what comes out of this node will always show frame 53 of the input. And here you can see now whatever I scrub to, it will always have this freezed frame. So this is pretty handy. And the same node we can use for other things as well though. For example, in this case, to be fair, it doesn't really make sense, but sometimes for caches and so on, it's helpful to kind of limit your input frame range. Now with an Alembic node, you actually don't have that problem, because if you try to read something outside of the range of the Alembic file, so let's go to frame 400, it will just give you the last frame it has. So this is kind of nice of the Alembic node by default. But if you have, let's say, a cache that you cached out or any other thing that has that problem, then you get an error if you try to read in something that is out of your range. So here this one goes from 15 to 90, and I've tried to read it in before that, and here you can see it's just my horse again, which is of scale. There you go. So if I try to read it in with a file node because it's cached out, then it will give me an error, and if I go further it will give me an error too. So we can change this actually by saying, okay, missing frames should not report an error, but just give no geometry, and then at least it doesn't give me an error, but it still doesn't solve the problem of a disappearing horse. So this is something I have all the time, and for this you can use the time shift as well by not changing actually the frame that it currently shows, but by changing the clamp. And here you can say clamp to both, for example. You can do this with the first and the last frame too. And then you can limit the input and the output, let's say, to the range that in my case, of course, makes sense. And then the cool thing is when you look through this node, it will, when you have something, when you request a frame before frame 15, it will always give you frame 15, and after frame 90, it will always give you frame 90. So this is a great way of limiting your input range so that you always get something where you know it's clean and without errors. This doesn't necessarily only happen to caches, but this is for me the most common case. But let's say you have an animation or whatever, I don't know, some stuff that you might want to limit to a certain range, then this is another thing you can do with a time shift. So actually let's name this by its function. The first one is a freeze frame. Then the next one is a time clamp. And let's look at the third option that I often use it for, and that is offsetting your animation. So in this case, what's kind of nice about this horse is it only starts at frame 15-ish, and then the animation starts, and then it stops at roughly frame 100. And this is actually quite nice for our purposes here, because now we have a reason to shift this. So we're actually using the node time shift for what it seems to be for, and that is offsetting. So what we want to do is we want to offset the old animation by 15 frames so that the first movement roughly happens on frame 1. And this is again where you can use the frame parameter. Now actually this is because I copied it, is the broken one. So let me quickly show you how to fix it. Very easy. We just type in $F and then the whole thing works again. And now the thing is, if you want to offset something, all you want to do is you want to, in our case for example, you want to have on frame 1 the frame 15 and so on. So all you have to do is you change your expression to frame plus, in my case, 15. And this means I'm now shifting everything that comes out of here by 15 frames into the future, meaning, as if I look through it, of course, if I look through this now, then the animation starts in the beginning, and I shifted the whole thing, in my case, by 50. Now, the problem with that approach is, and you can see it's not built in, unfortunately, which is a bit weird. There is actually no node, at least no easier node, that does this for you. So I use, or many people use the time shift for that. But the problem with this direct approach of just typing it in, and I'm guilty of sometimes doing this, is that someone who comes into your shot later on will not instantly understand that necessarily. So what I would recommend, and the other reason is it's more easy to control the way I do it next, instead of typing this number in directly, I would actually use it with a custom parameter. So I call this custom parameter offset, and currently it doesn't work because the parameter offset doesn't exist. So we have to actually go in, and this is a bit annoying. And I already filtered for integer because I know I would need that. I need an integer parameter, and I put this next to frame, which is here, and call this then offset. And that means I now have an additional controller here where I can just type in the offset, which makes it a bit more elegant and potentially easier to understand for people later. Now the cool thing is you don't have to do this every single time you need an offset, because if you've done it once, you can create a preset for this node, and you can call this time offset. And the next time, save preset, and next time you create a time shift, you will now here under the cogwheel have time offset as an option, and then it brings back your preset that you just created. And this is a pretty cool workflow to build your own offset function. And now my time is offsetted by 30. And by the way, of course, you can also do this with negative numbers. So there you go. And now it takes 30 frames longer before the animation starts. Now, if you're a bit confused if it's a plus or a minus, then you're like me, and that's totally fine. Don't worry. Just, try it out. As long as you understand this concept here, that's fine. And the last case we want to look at is how to speed up or slow down an animation. So in this particular case, it doesn't really make sense because the speed, of course, is fine. But let's say we want to speed this up twice. I guess you can imagine how to do that. You just take another time shift, and you just multiply the current frame by 2. And if you run this now, it's twice the speed. Okay. And the opposite is also true, of course. If you divide it by 2 or multiply it by 0.5, of course, then you slow it down by half. Now, this is fine for simple stuff. Before I finish this, let me point out why you should definitely watch the next video. This actually works fine when you multiply it by 2 because there's basically frames lost, and it will be fine. But when you divide it or when you slow it down, you have actually a problem. And let me show you that by slowing it down even further. For example, multiplying it by 0.2, and let's go close and watch it. And by the way, when you change the speed, sometimes you might need to combine that with an offset because, as you can see here now, it takes much longer before the actual animation starts. So it's not uncommon that you combine the two. But anyway, what I wanted to show you is if you slow your animation down, and here I created a flipbook to show you the problem a bit clearer. And here you can see the stepping. It's not a smooth movement. It jumps from frame to frame, basically. And the reason for that is it basically tries to read out frames that don't exist. So if we look at any frame, let's say this one, it tries to read out frame 9.5 from the alembic node, which then is just rounded to 9 or 10, because in the alembic there is no frame 9.5. Now, to be precise, actually you can save multiple subframes in an Alembic, but very often you don't have that, because we will see in the next video that you can interpolate between those. So keep in mind, whenever you slow something down, then the time shift node is not really ideal. But for simple stuff like multiplying it by 2, so especially speeding up, can work without a problem with the time shift. And you can see now that there's a lot of stuff you can do with the time shift node. You can freeze a frame, you can clamp a range, you can offset your time, and you can even speed it up or slow it down. But be careful with that one. We'll look in the next video a much better way of doing this to create the subframes. So yeah, I hope this was helpful. That was the time shift node. Thanks very much and see you later. Cheers.